Hello guys, welcome to Think Backend. In this series, we'll learn about HLD, high level design. When we are giving interviews for any companies as a software engineer, software developer, right? Earlier, just DSA was very much important, but now if you see, like system design is very much important. Like in any company, if you see one round of DSA, then one round of HLD, one round of LLD, it is there, right? It is very much important that we understand in depth like what is HLD and what is LLD. So in this series, I'll be covering that only. It will be purely interview based, right? And beginner friendly as well, so that anyone can understand this. So I'll cover the basic concepts and the most important concepts that are asked in interviews. So let's do it together. Yeah. So let's start. So basically, uh, you know, uh, we don't have to cram anything in HLD. HLD has very limited concepts. It's very much important for you to understand, like, we should be able to give reasoning for everything. So, I'm sorry, one second. When I talk about HLD, right? HLD, it's basically about answering why. Why for everything? If you are using anything, any particular thing, you have decided to go ahead with a particular cache, you have decided to go ahead with a particular DB, right? It is just like giving reasoning. You should be able to answer like why you have selected this cache, or if you have selected NoSQL data structure, or you have selected SQL data structure. So why? You should be able to answer the why for anything. So there is absolutely no right or wrong in HLD. There can be different things. Just you should be able to answer the trade-offs. You should know that why, which is better than that. So basically, there are things like there are scenarios where different things apply, right? So you should be if you are able to answer these two things, why and this the trade-off of particular thing, that if I'm selecting one thing over other thing, why it is better. Yeah, you are good. So for this, we need to have clarity. So firstly, we'll understand the basic things, basic and in the depth. What is it? Okay. So firstly, we'll study about networking. Yeah, let's do it. Okay. So one second. Yeah. So networking. So what is networking, right? And why we are studying this? Before going into anything, we there are uh, in any big system design, right? There are many components actually. So you should know that what are these components, right? And how do they communicate? Like how the communication is happening, right? So first, like very first thing that you need to understand is what is the client server architecture. Like, okay, client server architecture. I'm very sorry for the handwriting, guys. Like, I'm trying my best to explain. I've just started with this, so ignore my handwriting. Yeah. So client server architecture, when I say these big words like client server, what is this? Like what is client? What is server, right? So basically, if I say anything, any system which is sending the request, so any system which is sending the request is the client, right? Like if I say web browsers like anything, Mozilla Firefox, Microsoft Edge, right? Chrome, like whenever you open Chrome, Google Chrome, you search for anything, okay, that system, it acts as a client that time because it is requesting for something, right? And one which is responding to the particular request is the server. So backend पे हमारे कुछ server होते हैं, okay? So whatever, whenever request comes, it goes to a particular server and the response is returned. So this is the client server architecture, right? You should, this I'm telling, I know this is very basics, but for any person who is new to this, so we should be he should be aware of these terms, right? Okay. Now, a very basic question I want to ask, like what happens actually when you open Google or anything, right? What happens when you search for anything? Like if you do google.com, right? Or if you do amazon.com, when you search for a particular thing, Amazon.com, particular site. So what happens? Like you are requesting as the client, what is happening? You are requesting for a particular thing. Like if you're typing Amazon.com, you probably want to get the homepage of Amazon. You're requesting Google.com, you are requesting for something. Now this is, and the homepage gets opened, right? Which consists of, like, if it is Amazon, there will be different products, different things, right? So this is UI. But how, like, have you ever given a thought to this thing? Like whenever a request is made, whenever you type google.com, what happens in backend? Have you ever given a thought to it? कि backend में हो क्या रहा है? So to understand this, like there is a very important concept that you need to understand is DNS. Most of you have heard of it, but yeah, this is very much important. Domain name server, right? So what is it? Like if I tell you in easy way, right? So that you remember it for long, you just don't cram it or read it for now, but yeah, you understand it in long run, right? So what happens? Like if you see in phone, like we have a app called Contacts, right? When you open Contacts, there are different names, right? There is name, and when we open like any name, there is a number to it, right? Any number, and then we can call on this number, right? So if one user wants to connect to another user, like we have some name and then we have some number, then the two users get connected, right? Similarly, what happens when you type google.com? Now what is happening when you type google.com? Now there is some request you are carrying, like client is making that I want to get, let's say the client is making any request to get the homepage, right? What is happening? This is domain name server. What this has, like domain name server, it consists of domain names mapped to the IP address, right? Domain name mapped to the, sorry, one second, just so sorry for this handwriting. Okay, I'll just draw it again. Yeah. So this DNS, domain name server, it has the, like a hash map, it has the entire mapping. So it has the mapping of, let's say, domain name and the IP address. I'll come to this. What is IP address? Okay. So so when the when the request is made, right? When you enter google.com, so your browser, basically whatever browser it is, Google, right, Chrome, Firefox, anything. So your browser asks DNS. So this is DNS, and this is your browser making a request, right? So your browser asks DNS, what is the IP address of google.com? Request is made, but it doesn't know where it has to go. We have typed google.com, but we have to know that, okay, where is google.com? What is the address of google.com, right? So in this, basically, DNS, what is domain name? It is like here, all the domain names are stored, like google.com, amazon.com, right? And there is like some kind of IP address. For example, I'm just taking any numbers right now, 250, 190, 14. So this is the IP address of google.com, right? So your browser asks, hey DNS, what is the IP address of google.com? So DNS replies with the IP address. So जब आपने, when you type this, you got in response the IP address, right? So now what is IP address? Like if you see like take for example google.com, imagine it is a restaurant, right? This is the name of the restaurant, but I don't know its location, है ना? So location or exact address will be something. So IP address is the location, exact address of this google.com. So if I want to go, I have to go to this IP address, then only I'll reach google.com. Similarly, IP in this DNS terms, domain name we have, IP address we have of this domain name. So whenever a request is made, the request goes to the particular IP address. And here only, like, basically like human talks. Names are for humans, like there are different humans, right? So we have names, but for machines, different machines, we have IPs, right? These IP addresses. So computers talk. How the computers talks, machines talk using IP addresses, right? Is this part clear? Now browser talks to server. Once browser gets to know the IP address of a particular domain, now browser says, okay, I know where Google lives. Let me send the request. Once it know where Google lives, it will send the request. Let's say the request is give me Google's homepage, right? Whatever you type, www.google.com or anything, you just type Google. So let's say the request is give me Google's homepage, right? One second. So the request travels through the internet to that IP. So this is the request. It will travel through the internet to that IP address we just figured out from the DNS. जो हमने DNS से we have fetched. Okay. And then at this point only load balancer enters. So there is a very important concept of, guys, this is like you must know what is load balancer. So load balancer is something like the request first comes to load balancer, and there is like when I say google.com, when I say amazon.com, there is not just only one server, right? There are many servers. So like who know, there should be something like when the client is sending some request, right? It has to send it to first before sending to an actual server, it will send it to load balancer. Now it is the task of load balancer to send the request to the particular server, right? So depending on the various conditions that we will learn later in the series, that basically with the health checks, which one is the like most healthy server, like which is the most healthy server, or which has less requests, which can handle more requests, right? Based on certain conditions, this load balancer will route the request to the particular server, right? So this thing is very much important. Like, so now I think now you are clear of like when you type google.com, what happens? The request travels. Like we first check the IP address. So it travels to DNS to check the request, to check the IP address of the requested domain. Then it goes to load balancer so that it can go to particular server, correct? Now, when it goes to a particular server, right? Now it decides request will go to which server. After that, now your request reaches one backend service, right? After that, like one, there will be like many services. So it will reach one backend service. So load balancer will route it to any of one service, right? There will be many services. So what will that do? So this server, it will like understands. तो यहाँ पर अगर हम जो एक backend service होगी उसका काम क्या होगा? What it will do? It will understand the request. What is the request? Correct? It will do some. It will run some business logic, and it will fetch the data and return. Like if anything required, it will fetch from DB and it will return the response. So this all we will study. Okay. I am just like giving you in like thumbs up the introduction, like how the request flows, how the response comes. Finally, we will get the response. Okay. So this is just a higher picture. It's nothing like that to get scared about. It's just the higher picture of how the request is flowing. Okay, so till right now, what we have covered so far, this is just one second. I'll just see. Yeah, I'm uh, okay. Client server, okay, domain name and everything. Now, let's come to another very much important concept, guys. Like this is basically you need to understand this. Now, if I talk about like networking, right? So let's start with the networking part. So what is networking? Now, since we have studied about this client server architecture, it's very much important that we should know that how actually the communication is happening and how uh, like how the data goes from one component to the another component, right? So like there are many layers to it, honestly, if you go very deep. So there are many layers how data travels actually, how what all happens. But since it is interview focused, we'll be probably focusing on two things which are important for you to understand. One is the transport layer, which we will focus on, and the second one is the application layer. Okay, so these are the two main layers we will be focusing on, transport layer and application layer, right? So coming to transport layer, okay, so if I talk about transport layer, let's understand it in depth. Okay, what is transport layer? It's basically like how the data is delivered. If I say like how data is delivered, Like data is something which is very big, very too much data is there, right? So, but how data is delivered is the question. Okay. So data delivery, basically, if I what is the role of transport layer? It is basically data delivery in small segments, right? Data, like if I upload some video, what do you think that the video automatically in one go it gets uploaded over the network? I just uploaded like too much big MB size video or audio file or video file. It takes GB also. Sometimes the videos are in GB also, and it gets uploaded as such. No, that doesn't happen. So data is like delivered in small segments. Okay. So if I say data is delivered in segments, okay, in small segments over network. When I say over network, guys, it means over internet. Okay, because I'll be using these terms in my whole series. So I'm just telling you now. Okay, now so data delivery in small segments over network is the work of transport layer. By the name only you are understanding that what does transport layer to transport the data packets, okay, from one component to another component. So now there are ways to do this, right? There are ways to do this. So like one way is there's one component A, one component B. It starts from here, right? It starts from here in full speed. Imagine you are carrying, okay, for this I'll just give you one example. Like you are here at point A and you have to reach to point B, and you are having let's say lots of some stones in your hand, right? Lots of stones in your hand, and you are running very fast. So like you are running in your full speed, right? So in the way, it is possible that you might drop one or two pebbles down, right? But your speed is full. So this is one way, right? Another way is, again, you have to start from point A and you are going to point B. Okay. And now you're here. Again, you are having some pebbles in your hand, but now you are moving slowly. So you are moving slowly, taking care of no pebbles to fall down. So speed is okay. There is no much speed, but you are like taking care of whatever you are having, not to lose them on the way. So here you are maintaining the reliability, you are maintaining the consistency, taking care of the things you are having. So with this only, like with this thinking, we come to like two main things, like how data is like traveled or transmitted over network. There are two main things that you should know. So one is UDP, other one is TCP. Okay. So with this, these are important, guys. So listen. So what is UDP and what is TCP, right? So when speed is priority, then it is UDP. So if I say UDP, UDP stands for what? User Datagram Protocol. Okay. It stands for what? User Datagram Protocol. And UDP, so when our speed is priority, so speed is priority. We want it to happen in full speed. We will use UDP. For example, live streaming. If I'm taking any class live, I want whatever I speak, you should instantly get it. Whatever you speak, I should instantly get it. Here and there, little bit consistency, okay. But we should be able to communicate without any much lag. Speed should be very much okay, right? Or online gaming. So example, I'll write like live streaming whenever I'm doing any live streaming, anyone is doing any live streaming, or let's say online gaming. So UDP will be preferred. Okay. Coming to TCP. Now, what is TCP? TCP stands for Transmission Control Protocol, right? Guys, I mean, when you will give interest now, you will feel that these things are very much interesting. So you have to just trust and stay. We can do it together, right? So transmission control protocol. Transmission control protocol is like whenever I want that I want my data to be reliable, to be transferred securely without any data lost, right? Without, it's very much important in big systems that we don't want any data loss. In that case, we can go ahead with TCP, right? So when I want safe, secure, because this is what? This is safe, secured, reliable. Okay. So it's very much important. So when focus is only on data part and not reliability, what you have to use? You have to use UDP. Otherwise, you have to, when you want reliability, consistency, you have to go ahead with TCP. Am I clear on this? Okay. Now I want you guys to think for a second, like to send a mail, right? In many systems, in many companies, these are basic things, communication and anything. Like to send a mail, what do you think? Which transfer protocol will be used? So these UDP and TCP, these both are what? These both are what? These both are transfer. This is what? Transport protocol. I'm sorry. Okay. So transport protocol. So now can you guys answer, like think yourself to send a mail, which protocol we will be using? So yeah, so whoever thought of like TCP, you guys are correct. Because TCP, we want that no data should be lost. Whatever content is shared, like it should be exact. There should not be like anything, even if it sends a little bit late, that's fine for us. But it should be reliable because need my data to be reliable. Okay. Also, like why TCP is slow? One thing, this transmission control UDP is very fast, but TCP is like slow because we know that it is when we have to when we want speed, we will choose this transport protocol UDP. Otherwise, we will choose TCP. But why it is not fast, right? Because there is something called three-way handshake. Like guys, it's not very much important for interview point of view, but it's just for your understanding. What is three-way handshake? It's like first a connection is established. Okay. So between a client and server, first a connection is established. Okay. And then like data transfer happens, transmission of data. Okay. Second is like transmission of data. And third is connection is terminated. Like connection is terminated. Okay. So all these things, nothing is there in UDP because of which is fast. It does not have to establish, it is connectionless basically. But in TCP, if this is my client and this is server, firstly, I have to make a connection, then I have to transfer whatever data I want to transfer, then it is terminated. Third point, it is terminated because of which it takes time. Okay, I hope you guys are clear with this. Okay. Now quickly, I'll just write down some points between the UDP and TCP. So you guys are very much clear with this. Okay. So, okay, UDP and let's say TCP. Okay. So I'll write some of the points. So first thing is, okay, so this is, if I see, this is connectionless, as I've explained you. In UDP, there is no connection, so this is connectionless. In short, we'll just, you should know, like there should not be much things that you should not know. Concepts are limited, as I told you. So guys, learn it by heart, right? And here it is connection oriented protocol. There is something called three-way handshake where you have to establish a connection first, right? Sorry, this is the first point. Then it is like, since it is connectionless, so there is no overhead of establishing the connection or maintaining or terminating. So no overhead, right, of maintaining, establishing, and terminating the connection, right? And terminating the connection. And here what are we having? We are having the overhead of maintaining the connection. Yeah. And third point, okay, one second. I should just go down. Okay. For you guys, I'll just write again here UDP and TCP so that you don't swap the things and take this wrong, right? UDP and TCP. Okay. So guys, I'm just new to all this, so please, like, just don't know to my like my handwriting is bad, I know. So yeah, with the sessions I'll take, I'll get to know more better. Okay, so if I talk about UDP, it is not reliable. It is unreliable because what it is offering speed. Its greatest strength is speed, but it is unreliable. Like delivery is not guaranteed, right? So in many big systems, we don't want that. We want like our delivery should be at least guaranteed. For that, we can use TCP. So here it is at least reliable. That is delivery guarantees the delivery of data, correct? Guarantees delivery of data. Okay. And like, okay, coming to the next point. Basically, it's like you can see it is faster. Obviously, it has speed. It is slower in comparison to that because that is mainly what is the difference. Yeah, there like here, if you see, there is no sequencing, no ordering. So no sequencing, nothing. Sorry, no sequencing. Here it is sequencing and ordering is done, right? You can say sequencing and ordering is done. One important point to take care of here is there is like in UDP, if even the packet is lost, there is no retransmission. If it is lost, it is lost. Okay, so there is no retransmission of packets, but here retransmission of lost packets happen. Okay, even by chance any packets get वैसे तो it doesn't get lost, ठीक है? Because that is it is consistent. But in case the any packets get lost, so retransmission of lost packets happen. Example, can you guys think of example? So coming to like UDP, can you give me example? Sending an no, sending an email will be TCP. Yeah. You have to just give a thought. Okay, what is the priority here? What is important here? In the starting, I told you to reason out the why thing. Okay, why sending an email? Because I want my data should not be lost. It should be reliable, right? I don't want anything to be lost here. Even if it sends a little late, is okay, but it should be at least sent, right? Here, but and like here, if I talk about is live streaming, online gaming, as I told you, I don't want any lag. Whatever I say, you should hear. Whatever you say, I should hear. Online gaming, right, is UDP. Am I clear, guys? I hope I am clear. Yeah. So these points are very much important. Like for the basic understanding, you should know all these points. Okay. So this was all about like the transport layer. Coming to the second important thing, like I told you, one is the transport layer, and second thing you have to study about is the application layer. So when I talk about application layer, what does I actually mean, right? So what I mean by application layer is basically like if there are components, how the communication is happening between the components. If there are different components, so how the communication is happening between them is taken care of what? It is taken care by application layer. Okay. So in this, we are going to study about like HTTP, HTTPS, right? I hope you guys have heard of HTTP. So this is what? Now, don't get scared like immediately. So, what is it? It stands for Hypertext Transfer Protocol. So, you guys know, like when we humans talk, we have certain language so that we can understand each other. Similarly, when computers talk, like they cannot talk in our language, right? So they also have some set of rules in which they can talk and they can understand each other. So one of that is our HTTP, okay? Hypertext Transfer Protocol. So you need to like it's important for us to understand this. Okay, so what is HTTP? How computers talk? So it is one of the protocol how they talk, right? So they need rules so both of them can understand each other. So if the browser is saying get home page and the server is returning the response, here is the page. So this is HTTP. So the browser requesting anything and getting the response, he's understanding, it is understanding what it is asking, it is delivering back. So this is what this is HTTP. Okay. It is just a protocol. It does not care about the security. Okay. Like anyone can on the network can read the data and modify the data. This is actually HTTP. Okay. So you should know like a little about it. HTTP is built on the top of what? Any idea? Anyone? So HTTP like does not data delivery. If I like, okay, we talk about how data, like in which language we are communicating, it is HTTP. But HTTP does not send data itself. It is built on the top of TCP, right? TCP just we studied transmission control protocol. right? It uses TCP. TCP promises reliable delivery. So it uses that. Now, guys, like there are different versions of, okay, yeah. So coming next. So there are different versions of HTTP that came in the market. Like earlier, it was like HTTP 1.1 version. Then next was like HTTP 2 version. Then it was like HTTP 3 versions. So obviously new versions come because there is something which is not there in old version and it is there in new version. So just for the knowledge point of view and for your understanding, I'll explain you what all these are, right? Now it's like think of HTTP like I told you it is the set of rules, right? For the communication. Think of it like ways of talking. Like over time, we improved how we talked. What are these versions? Over time, we improved how we talk. Like, agar, if you remember, like, in the old times, there was no phones also. People used to communicate using like letters, right? Then landlines came, then mobile phones came. So the purpose was same to communicate, but it improved. Similarly, this is how we talk. The purpose is same, but there is improvement in every version of it. Okay, so let's start with every version. Okay, so let's start with the first version first. So it is like HTTP 1.1 version. What is it now? It is basically one request. So it is basically what? So one request and like one response. We get one response, like mostly one request at a time per connection. Okay, so if there is one connection, let's say one connection is established. So like firstly, one connection is established. So the request is sent and we cannot send another request till the time the response came up. So it is sequential in nature. So it's little slow, obviously, because it is sequential in nature. Yes. So it is built on top of TCP. We have done this. So it is, so the cons in this was it is slow because it is sequential. It is waiting for the response to be covered. Yeah. And next request waits for previous response. Yeah. It is waiting for the previous response. Waiting for previous response. Okay. And like we can, so this is slow. Then comes like HTTP version 2. What is it? It uses one persistent. It got better. Instead of like whenever we are sending another request, we have to establish the connection again, right? It uses just one persistent connection is there. One persistent connection is there. So it supports multiplexing. What does that mean, right? I'll explain everything, guys. Uh, it supports multiplexing. Now, what does that mean? Basically, like multiple, like there's one persistent connection is not breaking. You can send as many requests and you can get as many responses, right? So there are multiple requests, there are multiple responses, all in parallel in one connection. So there is one connection and all this request going, request response coming, it is happening in one connection and it is happening in parallel. So we can see it is way better than HTTP 1.1 version. Yeah. So it is also built on over on the top of TCP Transfer Control Protocol, right? This is the transport protocol. Yeah, still it is affected by, since still there is like one con here, like cons in the cons it is like still it's like affected by TCP packet loss. In case any packet gets lost, it can slow everything. Still it can slow everything if any packet is lost. So retransmission, it will that will take time, right? So then to cater to that, in third, like HTTP version 3 came up to solve that problem. New versions get introduced, bringing new things which the older versions didn't had, right? So HTTP 3 is what? So this came up in 2020. Recently only HTTP 3 came up. This is built on the top of UDP. Okay, guys, this is built on the top of UDP. Now, and HTTP 3 for this, Google came up with something called, like Google came up with something called Quick, QUIC, which is basically which stands for Quick UDP Internet Connections. Okay. just have to, not everything you have to remember. Just I want your concepts to be cleared, so you know that okay, there's something HTTP, there are different versions to it. You know what is there in market, okay? So why was it needed? Like why was Google came up with Quick? So why, the question is, why was it needed? Why was it needed? Like you should be able to answer why, if there is something, why it is. TCP is reliable, we know, but we also saw the con that TCP, like in TCP, there is slow recovery on packet loss, right? There was slow recovery. So what HTTP 3 uses, it uses Quick protocol, which is built on UDP, and we know that UDP is fast also. Yeah, it is. Like if I say Quick is reliable actually, and it provides security as well. So, like mostly it provides the features of both, like the TCP and UTP. This Quick. Okay, so which is used by today? It is used by this Quick is used by Google. It is used by YouTube and all the like modern browsers coming up. It is used by everything. So yeah, this was so this is one of the protocol, right? So the versions we have studied HTTP 1, 2.1, 2, and 3. And like I think video is getting long. So in the next video, I will just read more about HTTP. What are the methods and what are the important interview question like that comes up usually related to these HTTP methods. That is very important to understand. So yeah, this much for now. Have a good day. Bye. Yeah, take care. So 1 second.